Here we go with some problems. Showed you in the last one. We'll play some games with their new properties we've learned. So let's jump into it. And this is what I showed you last time, where we're going to be given three pieces of information. The integral from 1 to 2 of our function f of x is equal to -4. We also have that the integral from 1 to 5, so they have the same starting point, but one just goes further. Same function is equal to 6. And we have another function, this g of x. It's different. It's not the same function, but it's going from 1 to 5, just like we had in the last one. We're saying that this is equal to 8. Now we're going to go through and solve a, b, c, d, e, and f. So let's go to it. Got them over here. So let's first just take a look at these. We have all of our information up above. Now this first one, there is nothing to do here, huh? We're going to set it equal to, we look and we see it's going from 2 to 2. Nothing to even look at. I don't give a shit what those answers say. The answer is 0. It's frickin' 0. That's the only thing it could be, because we're going from some point A to some point A, where there is absolutely no width. Now we go to part B. Shit, there's not much going on here with part B. It's that property about flipping bounds. The only information we are given is that we go from 1 to 5 of g of x is equal to 8. But now this is asking us to go from 5 to 1. So we can say, well, this is equal to the negative from 1 to 5 gx dx. We just flipped our bounds. And then we can use our key from up above saying it equals 8. So we will replace it with an 8. We replace it with the 8, except now it's -8. The opposite. So when you flip your bounds, you just get the opposite number. Come on, this ain't bad, right? Mellow, mellow, mellow. Let's go to our next. Let's go get C and D. So this is asking us, let's look at C. We have 3 times the function. But the only thing from 1 to 2, the only thing we know from 1 to 2 is just a function. So we're going to use that little coefficient trick by yanking it out to the front. It's just a number. Get that shit out of there. Get it to the outside. So we can say that this is equal to 3 times the limit, or the integral from 1 to 2 of f of x dx. But we know this. It's right here. Right there. That shit's equal to -4. So we're just going to replace it in with -4. Alright, the answer is 3 times, and the replacement was -4. For an answer of -12. Okay. Property. Not rough. This is not rough. But now we get a little tougher here. Let's look at D. D requires a little bit more thought. So we're dealing with our f of x. So we're either dealing with this one or this one. But it says we're going from 2 to 5. I don't see anything from 2 to 5. Let's think, just on the number line. We'll just play with the number line. Like this. So we go 1, 2, 3, 4, and 5. Well, we know the area under the curve from our first one, from 1 to 2, so it goes from 1 to 2. And then we also know our area from 1 to 5. This goes all the way to 1 to 5. This question is actually asking us, what's this? What's this? So if we were just dealing with the numbers, right, it wouldn't just be the differences between the two of them. Well, let's write it that this is actually the same thing as the integral from 1 to 5 of our function minus the integral from 1 to 2 of our function. Right? As we do this, that would be a minus. We wouldn't take the whole thing from 1 to 5. The whole thing from 1 to 5 goes from here to here. We had to subtract out. We had to get rid of all this shit back here. We go, no, not the 1 to 2, which just leaves us with from 2 to 5. That's a big concept. That's that shit you need to be able to do, and now we can just pop it in. From 1 to 5 is equal to 6 minus whatever the answer is here. That's -4, so we get minus -4, and our answer is 10. Games with some properties. mellow ass games. That one's probably the roughest. Let's see our last two. I think D was the tough one. I think we're good to go. Let's do 1 and 5. Now, I don't want to play around with this. We're just going to say this is equal from 1 to 5. 1 to 5 of f of x dx minus, and then we break it into pieces. We learned that part. We already know that from derivatives and limits and everything we've ever done in our entire freaking lives. So now we just put our answers in. From 1 to 5, for f of x, we get 6. For g of x, we get 8. We pop it in and we think 6 minus 8 is equal to -2. Huzzah, we found ourselves a solution. Oh, did I write 2 and say -2? I did. It's -2. Don't send me a message on that, please. All right. Lastly, we're going to actually put together a couple things. We're going to deal with our constant, and we'll deal with that minus. We're going to do both of them, but we're going to do it all in one shot. We're going to do it all in one big shot. Let's go. That this is equal to 4 times the integral from 1 to 5 of our f of x dx. I broke that shit up and yanked the 4 out at the same time. That's not too much, is it? And now we keep our minus sign and we just write our integration symbol again. And then we say from g of x dx. And notice I'm writing that dx every single frickin' time, right? You got to get that in, saying what you're doing this with respect to. So now we can replace in our answers because we know something from 1 to 5, right? That's right here. That's 6. Pop it in. And then our g of x from 1 to 5, of course, is right over here, and that's 8. So we'll pop in our 8. PEMDAS tells us 4 times 6 is 24. Then we subtract out the 8, and we get a solution of 16. There's the property games. I like the property games. They're pretty simple. If you practice them, you even look at them, shit, I'd probably assign it to you. You won't even do any of this work. You'll probably watch this after I gave you the test. Hey, that's how you solve your problems. Well, these problems, not your other problems. That's on you. You can deal with that shit. I'm just here for the math stuff.